we thought that AI would revolutionize computer graphics. Just as GeForce brought AI to the world, AI is now going to go back and revolutionize how computer graphics is done altogether. Well, today I'm going to show you something of the future. This is our next generation of graphics technology. We call it neural rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS 5. Take a look at it.
I found this driver. No, seriously. I'm not joking. What I'm about to show you will make your $2,000 graphics card look like a potato from 2010. We are talking about DOS 5. And this isn't just another frame generation update. This is neural rendering. Everyone has been speculating about path tracing being the holy grail. And NVIDIA just said, what if we skip the math entirely and just generate the whole game? We are looking at a 600% performance increase. Yes, 600%. And it looks better than native fork. How is that possible? Buckle up, because today we are breaking down neural texture compression, ray reconstruction 2.0, and real-time generative AI that will change gaming forever. But first, if you're new here, smash that like button. Let's get this to 100,000 likes, because if NVIDIA sees this, they might delete my access. Let's dive in. To understand why DOS 5 is pure wizardry, we have to remember the dark ages. Remember when we used to render everything, pixel by pixel, shader by shader. DOS 1 was a blurry mess. DOS 2 was magic. DOS 3 gave us frames out of thin air, but it came with latency. DOS 3.5 fixed the lighting. It was cool, but it was still reactive. The AI was guessing what the next frame would look like based on the previous frame. Here is the bottleneck. The game engine calculates physics, polygons, and lighting. Then it throws all that data at the GPU. And the GPU screams, I can't handle all these rays. Then DOS comes in and cleans up the mess. But the foundational game engine hasn't changed in 30 years. It's just triangles and math. It's incredibly inefficient. With the jump to Unreal Engine 5 and Nanite, we have billions of triangles. Path tracing. That's 1,000,000 light rays per pixel. Even an RTX 970 Ti Ultra Super Max struggles to hit 30 fps native fork with that. So NVIDIA looked at the problem and said, forget the math. Let's just use a bigger AI. This isn't just a upscaling anymore. This is a replacement. DLSS 5 replaces the rasterizer entirely. So, what actually is DOS 5? NVIDIA is calling this neural rendering. There are 3 pillars here, and every single one is absolutely unhinged. Number 1. Neural texture compression. Textures eat from for breakfast. A single fork texture is massive. In DOS 5, the AI doesn't store the texture, it stores a weight map. It's basically a math equation that generates the texture on the fly. We are talking about a 95% reduction in VRAM usage. That means you can run max settings textures on an 8GB card without stuttering. And the best part, because the AI generates the detail, there is zero texture pop in. The grass in Cyberpunk doesn't just appear, it materializes perfectly. But that's just the warm-up. Let's talk about Pillar 2. Ray reconstruction is old news, but version 2.0 is something else entirely. It doesn't just denoise the light, it predicts the light. The AI has been trained on actual physics. It knows how light bounces. So when your GPU sends it a noisy mess of grainy pixels, the AI says, "Oh, I see what you're trying to draw." And it literally redraws the lighting based on context. If a character is holding a red balloon, The A knows the skin should have a reddish tint. It creates global illumination without calculating a single bounce. That's a massive workload removed from the GPU. But Pillar 3. This is the one that scares developers. The generative frame. DOS 3 inserted frames between real frames. DOS 5 generates the entire frame based on the previous frame and your controller input. NVIDIA trained the A to understand game physics. You press U. The A knows the character moves forward. It generates the new frame speculatively. The GPU now only has to render every fourth frame. That means your frame rate is essentially multiplied by 4, or 5, or 10. It's only limited by how fast the A inference chip on the GPU can run up the rendering cores. Now, if you're a competitive gamer, you just heard generative frame and felt your eye twitch. Latency. Input lag. If the A guesses the frame, and it guesses wrong, or takes too long, the game feels mushy. We've all been there. DOS 3 had Reflex to fix that. For DOS 5, they have something called Reflex 2.0, or the neural input warp. Here's the secret sauce. The A doesn't generate the frame blindly. It takes the last real rendered frame, and it warps it based on the exact position of your mouse milliseconds later. Think of it like motion smoothing on a TIG, but we're using raw input data from the GPU. This reduces latency to less than 10 milliseconds. Is it as good as 200 fps native? Technically, no. But is it good enough? Actually, yes. It feels snappy. So casual gamers, you won't notice the difference. Competitive gamers, you turn this off for Valorant or X2 anyway. But for single-player, story-driven experiences, this is the ultimate immersion. And the best part, no ghosting, no artifacts, just pure, buttery smooth gameplay. So, what does this mean for us? For the gaming industry? This is a paradigm shift. For game developers, it means you don't have to optimize anymore. Not really. You just build the high poly model, dump the raw data, and let the A figure out how to run it on a phone, a laptop, or a high-end PC. You will have the game engine and the A renderer. They are decoupled. This could kill traditional rasterization in the next 5 years. But here's the warning. NVIDIA controls the A. If the A hallucinates, it breaks immersion. If it hallucinates wrong, your character might end up with 6 fingers. We are trusting the machine to draw the world for us. And while it's doing an incredible job, we still need that baseline accuracy. It's an exciting time. But it's also weird. And here's the bigger picture. This technology isn't just for gaming. We're talking about film production, virtual reality, architectural visualization. Any industry that relies on rendering is about to be disrupted. The A doesn't just speed things up. It fundamentally changes how we create digital worlds. Is DOS 5 the future? Yes, without a doubt. It's not a gimmick, it's the solution to the insatiable demand for high-res gaming. If you want to play Cyberpunk at 240 Hz with ray tracing cranked to the absolute max, this is the only way. The hardware simply can't do it alone. It needs the A. Should you buy a 5000 series card for this? Well, you'll have to wait for the next video where I test the thermals. Because this thing runs hot. Let's recap what we covered today. We talked about neural texture compression that slashes from usage by 95%. We covered ray reconstruction 2.0 that predicts lighting instead of calculating it. and we dove into the generative frame that lets the AI draw entire frames without the GPU breaking a sweat. Oh, and we also addressed the latency concerns with Reflex 2.0. The bottom line: this isn't incremental improvement. This is a revolution. We're moving from hardware-limited rendering to AI-driven generation. And whether you love it or hate it, this is where gaming is heading. That's it for today. Like, subscribe, and ring the bell so you don't miss the benchmarks. I'm Marcel, and I'll see you in the next one.